What is a particle? You might tell me it's the fundamental building block of nature and makes up everything in the universe. You might tell me it's a wave function behaving both as though a particle and a wave. But these things only tell me what particles do and how they behave. What is a particle?
The idea of what a particle really is has to do with fields. And well, you know what fields are. You've heard of magnetic fields, gravitational fields. Today I'm going to talk to you about quantum fields. To make things easier, let's take one particular type of quantum field, the electron field.
The electron field exists everywhere in your home, your morning cup of coffee, even where there are no electrons present. It permeates the entire universe and it has ripples and waves like that of an ocean due to a very important principle of quantum mechanics.
The Heisenberg uncertainty principle. This tells us that the more accurately we know a particle's momentum, the less accurately we know its position, and vice versa. In this equation, delta x and delta p correspond to uncertainty in position and momentum respectively. Let's say an object is at rest, delta p is 0. But this equation doesn't seem to make sense. That's because this case is not possible. Quantum fields obey this rule. Thus, they are always moving, they are always fluctuating.
These fluctuations are known as quantum field excitations and they are ultimately what we call particles.
How do vibrations of a field give rise to fundamental properties like mass and charge that we know particles have? Let me explain this to you with the help of an example.
A ping pong ball usually feels light, but try moving it around in a container filled with water. It suddenly behaves heavier.
The mass of the ball hasn't changed. It's just that when it interacts with water, it behaves as though it's heavier.
Similarly, when particle fields interact with something known as the Higgs field, they behave as though they have mass, and when they interact with the electromagnetic field, they behave as though they have charge. This is how we get these two quantities. There are 13 particle fields and 4 force fields that explain, well, everything. The way these fields fluctuate and interact creates the fundamental particles and gives them their properties.
This is quantum field theory, one of the most important and fundamental theories in quantum physics. It is the best understanding we have of the universe right now and has led to the development of some really interesting theories that provide a potential breakthrough in the way we view the universe, such as supersymmetry, string theory, and quantum gravity, all of which have far reaching implications. So, this is, according to me and a lot of other people, possibly the coolest thing to exist in physics.